Imagine you're in a spaceship, cruising through the endless silent void of space. Stars twinkle in the distance as galaxies spiral beautifully around you. Suddenly, something incredible emerges ahead, a mesmerizing tunnel of swirling light and color. You've just encountered one of the universe's greatest mysteries, a wormhole. But what exactly is a wormhole? In its simplest explanation, a wormhole is a theoretical passageway, a bridge connecting two distant points in space and time, allowing for nearly instantaneous travel between them. Think about folding a piece of paper so two distant points directly touch, and then poking a hole straight through to join them. This is the essence of a wormhole. Wormholes trace their origins back to 1935, when Albert Einstein and his colleague Einstein-Rosen first described them mathematically. Originally called Einstein-Rosen bridges, these tunnels were proposed as theoretical solutions to Einstein's equations of general relativity, suggesting space and time might bend and fold dramatically under specific gravitational conditions. Though Einstein himself viewed these bridges as mathematical curiosities, modern physicists take the possibility seriously, exploring whether nature actually permits their existence. Einstein's equations show that gravity isn't merely a force, but a curvature of space-time itself, meaning wormholes might naturally form in extreme environments where space and time are drastically distorted. Wormholes theoretically consist of two key components: a black hole, where matter and energy enter, and its hypothesized counterpart, a white hole, which expels matter and energy outwards. Entering a black hole would expose you to gravity so powerful that not even light can escape. Conversely, a white hole would forcefully eject anything near it, potentially serving as the exit point. If wormholes truly exist, they could fundamentally change the nature of space exploration, allowing humanity to travel instantly between galaxies, potentially even through time itself. But let's explore further. What would it actually feel like to journey through one? Entering a wormhole would not be a gentle experience. Initially, you'd encounter immense tidal forces. The gravitational pull might stretch and compress your spaceship and everything inside, a phenomenon often called Spaghettification. This force could be strong enough to tear your spacecraft apart entirely. If somehow you survived, you'd rapidly traverse a surreal corridor linking two distant locations in space-time, emerging moments later, possibly across galaxies or even millennia. Yet, all this assumes you'd encounter a stable wormhole, something astronomically difficult to find or create. Stable wormholes remain open and traversable for extended periods, providing sufficient time for spacecraft, objects, or even human explorers to safely enter, navigate through, and emerge from the other side without experiencing catastrophic gravitational collapse. Unstable wormholes, on the other hand, exist only momentarily, rapidly collapsing under their immense gravitational forces almost immediately after formation, making it impossible for spacecraft or explorers to safely enter or pass through without being destroyed. Naturally occurring wormholes could theoretically emerge from catastrophic events, like massive star collapses, quantum fluctuations in the early universe, or collisions between cosmic bodies. However, these wormholes would likely be incredibly tiny, unstable, and fleeting, disappearing almost instantly after formation. If wormholes truly allow instantaneous travel, it brings up perplexing paradoxes, especially concerning time travel. Imagine traveling through a wormhole and emerging before you entered it, potentially meeting your past self or altering historical events. Such scenarios lead to mind-bending paradoxes like the famous grandfather paradox, where a time traveler prevents their grandparents from meeting, erasing their own existence. Physicists grapple with these paradoxes, suggesting various solutions like parallel universes or self-consistent timelines. Yet these remain untested. Time travel through wormholes is exciting yet deeply complex, raising philosophical questions about causality, reality, and our place in the universe. But to utilize a wormhole for space travel, we would need to stabilize and enlarge it. This brings us to exotic matter, a mysterious form of matter that's purely theoretical, yet essential for wormhole stability. Exotic matter is unique because it possesses negative energy density, effectively producing a gravitational push instead of a pull. Imagine gravity pushing outward rather than pulling inward. This fascinating property could counteract the extreme gravitational forces within a wormhole, preventing it from collapsing instantly. While exotic matter remains speculative, physicists believe it might exist under very specialized quantum conditions. It could possibly be generated in futuristic particle accelerators or through unknown cosmic processes. But right now, producing or harnessing exotic matter is far beyond humanity's technological reach. Even if we mastered exotic matter and stabilized a wormhole, navigating one could be extraordinarily perilous. Wormholes might be filled with intense radiation fields, gamma rays, or charged particles that could instantly damage or destroy a spacecraft. Additionally, wormhole entrances and exits might shift unpredictably, changing destination points without warning, making precise navigation nearly impossible. Travelers might exit the tunnel in unexpected locations, or even times. Moreover, tidal gravitational forces near a wormhole's entrance might stretch and crush spacecraft, requiring advanced shielding or gravitational dampeners to protect human life. These substantial technological hurdles mean wormhole travel remains far beyond current scientific and engineering capabilities. Quantum entanglement offers another intriguing connection to wormholes. Some physicists hypothesize that microscopic wormholes might exist at quantum scales, intimately linked with the phenomenon of quantum entanglement, particles connected over vast distances, instantly affecting each other's state. This tantalizing idea suggests that wormholes might play a hidden role in quantum communication or future quantum computers, transforming technology and space exploration in ways we can barely imagine today. But how exactly could we confirm the existence of wormholes in our universe? Scientists have proposed several intriguing methods. First, astronomers might detect wormholes by carefully observing gravitational lensing effects. Just like black holes, wormholes would dramatically warp the light of stars or galaxies behind them, creating unusual visual signatures or distortions that telescopes could pick up. By carefully analyzing these distortions, scientists might distinguish wormholes from regular black holes or neutron stars. Second, physicists suggest looking for unusual patterns in radiation, especially gamma-ray bursts or radio waves that might pass through a wormhole from distant regions of the universe. If wormholes truly connect vastly separated points in space-time, certain signals might arrive unexpectedly, revealing cosmic shortcuts hidden in plain sight. Additionally, gravitational wave detectors like LIGO might pick up specific signals that differ from standard black hole mergers. Wormholes could generate unique gravitational wave signatures as they form, collapse, or interact with other massive objects. Observing such a distinct gravitational wave fingerprint would strongly suggest the existence of wormholes. Finally, on a quantum level, laboratories might someday create or detect exotic matter, perhaps at high-energy particle accelerators like CERN's Large Hadron Collider. Discovering negative energy particles or anomalies in quantum fields could indirectly indicate that conditions suitable for wormholes are genuinely possible. Although these detections remain theoretical, science continues to push the boundaries of possibility, bringing wormholes from fiction ever closer to scientific reality. Now, as you gaze into the night sky, remember that wormholes, these incredible cosmic shortcuts, could someday become humanity's ultimate frontier. While many mysteries remain unsolved, our endless curiosity and ingenuity continue to push the boundaries of science forward. Perhaps, one day soon, we'll unlock the secrets hidden within wormholes, enabling journeys once confined only to our dreams. Until then, keep wondering, keep exploring, and remain inspired by the infinite possibilities waiting out there among the stars. Thank you for embarking on this cosmic adventure. Please like, subscribe, and keep exploring. The universe awaits on the other side.